So, Dr. D, PJ tells us that your train set's pretty cool and that you're having problems with it. Have you figured out what was wrong yet?
Not yet, but I'll bet if we work together as a group and check out the variables one at a time, we'll find the problem.
Okay.
What's a variable?
A variable is one specific thing that can affect or change the end result or the answer.
I've got an idea. I bet it's the wall outlet. There's no electricity there, nothing else will work.
Let's make that our first variable. How can we check out the wall outlet?
We can plug in something that we know works.
Exactly right. I've got a plasma ball we can use. Let's turn the lights down a little so we can see it better, and we'll plug it in over there to make sure that it's working.
Cool.
Now let's plug it into the same outlet the train setup uses.
It works fine. I guess you've eliminated one possible variable.
I'll check out a couple of other things later. By the way, how are you coming along with your electricity mystery?
Well, we still think lightning caused the power outage across the street from the treehouse.
We know that lightning doesn't cause electricity, but we're still not sure where it comes from. Can you tell us?
Well, electricity is electric charges flowing through the wires of a circuit. In a standard circuit, the charges are electrons. There are several ways to force the charges to flow. Do you know what some of them are?
Don't batteries produce electricity?
That's right. In fact, we can make our own battery out of lemons or other pieces of fruit.
A battery? From fruit?
Sure. A flashlight or the battery in your parents' car isn't made of lemons, but it works using the same principles.
Can you use a lemon to power something?
Let's see. I've got a little LCD clock. It normally works with a watch battery, about 1.5 volts. Hook together some lemons like this, and let's see what happens.
It's working.
That's amazing.
Can you think of another way to create electricity?
How about solar power?
That's called a solar cell, isn't it? I saw on TV that NASA uses solar cells to power satellites and even the International Space Station.
That's right. Look at this solar-powered bicyclist here. The brighter the light, the faster he pedals. So do you know how solar cells and batteries cause the charges to flow?
What do you mean?
Electricity doesn't appear out of nowhere. A very important law of physics says you can't get something for nothing. It takes work to push the charges through the wires, and the energy to do that work must come from someplace. With a solar cell, it uses the energy of the sun, and batteries use chemical energy. What other kinds of sources of electricity are there?
A power company is the source of electricity. It's easy to plug into our outlets and get power. But I guess I don't know how they produce it. Do they use a battery?
No, that's a good guess. The power company uses mechanical motion, however, to create electricity. Let me illustrate. Turn this crank and tell me what happens.
The faster I turn the handle, the brighter the light bulb glows.
That's right. When you turn the handle, you're providing the energy to force the electrons to move through the wire. The motion of the charges through the wire is called a current. Now this time, turn the crank, keep your eyes closed, and tell me when something happens.
Wow, it's a lot easier to turn now. What happened?
I screwed the light bulb. It only takes work to turn the crank as long as you're lighting the bulb. We're only lighting one bulb. Let's add some more bulbs, see if it's harder to turn the crank. All right, go ahead.
Whoa, it's a lot harder now. I'm really having to work at this.
But Dr. D, obviously people don't turn the cranks in a power plant.
What other sources of energy could you use other than people power to turn the crank?
We can use wind power to turn the crank.
Well, wind power is used to create electricity, but it's not often used for large-scale power production.
I think the power plant in our town uses natural gas.
That's right. Power plants use coal, oil, natural gas, and even nuclear fission to provide the energy to create electricity. In each of these cases, the burning of coal, oil, natural gas, and the fission of uranium provides the heat to produce steam. The steam causes a turbine to spin, which turns the crank and the generator producing the electricity. It's just like our experiment, but with more power. There's another natural process that can be used to provide the energy to create electricity. Do you know what it is?
Isn't it flowing water?
That's right. When water flows downhill, it has the energy to turn the turbine. One of the most interesting power projects in the United States is at Niagara Falls. Why don't you check it out?
Okay, I'll email them and see if we can talk to them about their facility.